This is week 5 lecture notes, and we're on geometric series. Let's make sure we have a definition that's clear. A geometric series is when we take a sequence and add up all of its terms. Now, we could have a sequence that's finite, that just stops, or we could have a sequence that goes on forever and ever, which is what this ... means. So if we take a look at the previous page, we had a whole bunch of sequences. So if I wanted to add up just the terms I see here in this first one, -2 plus 4 plus -8 plus 16, I could use this first formula, sum of a finite series. Now, believe it or not, you can actually add up an infinite number of terms. It's hard to get your head around, but you can actually add up an infinite number of terms. So I could put into my calculator -2 plus 4 plus -8 plus 16 plus the next one would be -32 plus the next one would be +64, etc. I couldn't ever put them all in because they go on forever. But this formula will actually give a total. It's amazing but true. So we're going to practice using the formula, and I'm going to depart from these notes and ask you to go to a piece of paper, and we're going to work with a simpler series first. So on a separate piece of paper, let's add this nice easy series. 2 plus 4 plus 8 plus 16 plus 32, and let's go one more, plus 64. Now, I'm going to go ... because we're going to add both a finite number of these terms and the infinite series. So we're going to take a look at the formula we're going to use. And if you haven't got a note card handy, pause the video and go get one, because you're going to want these formulas on a note card. And I've got one handy here. I'm just going to grab it. And I've got a note card with the sum of a finite series. And on your note card, you're going to want to explain everything. So turn the video off and copy the formula down, and then come on back and we'll label all the parts. Alright, if you're back, S sub n, this side of the formula, is the final total that we're going to get once we add up the terms we need. A sub 1 is the first term in the series. Now, then we do 1 subtract the common ratio, and you know how to find the common ratio from the previous page. And the n is the number of terms you're adding up. You're adding up 12 of them, put a 12 there. And then on the bottom we do 1 minus that common ratio again. Alright, pause the video and make sure you get your note card filled out with all these labels, because we're going to use it now to find the sum of, how about we find the sum of the first 1, 2, 3, 4, 5 terms. Sum of from here to here in this series. So it's just a matter of plugging and chugging. We're going to be finding S sub 5, the sum of 5 terms of the series. Equals the first term, it's a 2, times 1 minus the common ratio. Alright, what are we multiplying by over and over again to get the next term? Well, remember what you can do? You can take any two of these and divide them. How about I take these two? 8 divided by the 1 before it. And you already knew the common ratio was 2, but if these were messier numbers, you'd want to remember how to do that. Any term divided by the 1 before. So my common ratio, R equals 2. So in my formula, I'm going to be doing 1 minus 2 to the n power. Well, my n is 5. I'm finding the sum of 5 terms. All that gets divided by 1 minus that common ratio again. Okay, let's do some simplifying here. This is going to be 2 times 2 to the 5th power is 32. So I'm going to have 1 minus 32. All over 1 minus 2, that's -1. Alright, so 2 times 1 minus 32 is -31 over -1. On top, we're going to have -62 divided by -1, and I get +62. Now, just for kicks and giggles, let's check that with our calculator. Is the sum of these 5 numbers really 62? Let's add them up and see. We get 2 plus 4 plus 8 plus 16 plus 32, and indeed it is 62. Now you're probably asking yourself, why would I use such a complicated formula to do what was so simple? Well, what if I'd asked you to find the sum of the first 100 terms? You certainly wouldn't want to enter 100 of those numbers in your calculator, but by using this formula and 100 here and here, you could do this quite quickly. Alright, tune in for part 2.